We use muscles in every activity that we do throughout the day. As I'm talking, muscles are contracting in my face. Let's dive deep into how an actual muscle contracts. Before we begin, we must know the anatomy of a muscle fiber. The green lines on the fiber are called Z-lines, where the actin is attached. They are at the end of a sarcomere. The tan section is the I-band. From one side of the purple section to the other side is the A-band, where thick and thin filaments overlap. In the H zone, the pink is in the middle. Finally, the blue line in the H zone is the M line, where only thick filaments are. A nerve impulse travels down the motor neuron axon, as shown by the arrow, and it reaches the synaptic cleft, which is between the motor neuron axon and the motor end plate. This impulse releases neurotransmitter molecules called acetylcholine, which are the triangles. The acetylcholine travels through the cleft and binds to receptors in the muscle fiber membrane. This increases membrane permeability to sodium ions. The sodium itself triggers the nerve impulse in the muscle contraction. The binding of the neurotransmitters triggers an electrical impulse. The impulse travels over the surface of the muscle fiber membrane and through the transverse tubules. In this case, I have one transverse tubule that is dark but turns light when an impulse travels through it. Over the muscle fiber is the sarcoplasmic reticulum, which contains a high concentration of calcium ions. In response to the electrical impulse, the calcium ions diffuse into the sarcoplasm of a muscle fiber. The calcium ions flow to the myofibrils, where the myosin and actin are located. The muscle contraction only occurs with the help of calcium ions. They have an association with the molecule troponin that is located on actin. Actin, in this case, is the green double helix. Once the calcium binds to the troponin, this reveals the binding sites for the myosin, that is to the left of actin. The tropomyosin that is covering the binding sites moves out of the way. When the muscle is relaxed, the tropomyosin blocks the binding sites. Once the binding sites are revealed, myosin can grab a hold of actin. To do so, it needs energy. An ATP comes in and is hydrolyzed to ADP in an inorganic phosphate. This allows for the myosin head to move and attach to a binding site on the actin. It moves the actin toward the M line and gets stuck there. An ATP comes in and connects to the myosin head to release it. This process continues for however much the muscle needs to contract. The actin and myosin are not shortening in length. The actin is just moving toward the M line. When all the actin filaments move toward the M line, the whole muscle fiber contracts. The Z lines get closer together and the sarcomeres shorten. Once the muscle is relaxed, the calcium ions flow back to the sarcoplasmic reticulum and the tropomyosin blocks the actin binding sites again. And that is the end of a muscle contraction.